Today we're going to take a look at section 5.5, day number 2, and this is going to be focusing on solving equations by factoring. In the previous lesson, we took a look at just factoring some equations, and we took a look at quadratic equations. We took a look at ones that had x to the third, x to the fourth, and more specifically, we looked at some special ones. And we looked at factoring, reviewed factoring perfect squares again, and we saw a little pattern where we did the square root of each number to get it to factor. And then the biggest thing that we looked at previously were perfect cubes. Okay, we worked on how to simplify and factor perfect cube polynomials. Okay, well today we're going to take it one step further. Okay, we're going to solve these equations. Okay, we're eventually going to factor them, okay, and then try to find the zeros. Okay, but just a little refresher on how to find the zeros. If I backtrack here a little bit, and I had things that were already in factored form, okay, like x plus 3 and x minus 5 equals 0. Okay, and I want to find the solutions. I want to find the zeros. If you remember what we did, okay, I have two things multiplying together to be 0, so I could set each one of these things equal to 0, and then solve each one separately. Okay, and if I did that, if I move the 3 over, I would get x equals negative 3. If I move the 5 over, x would equal positive 5. Okay, but we could write those two little equations, set each one equal to 0, and then solve them individually. And back when we did these ones, many of you remember a shortcut where it was just the opposite of what it looked like. If it was x plus 3, it came out to be negative 3. X minus 5, it came out to be positive 5. Okay, those are the nice ones. Same thing with this one. Okay, factors nicely. I have a product of two things that equals 0. That means 2x plus 7 has to be 0. Or 6x minus 5 has to be 0. And then I solve each one separately. If I subtract 7, and then I divide by 2, x is negative 7 halves for the first one. And this one, if I add 5 and divide by 6, x equals 5/6. Okay, and likewise, when we did these previously, you maybe saw a shortcut with these where I could go from there to there and there to there. And it was the opposite of this number, negative 7, divided by the coefficient. Negative 7 over 2. Same thing over here, positive 5 over 6. Okay, and if you recognize that shortcut, great. But if not, okay, we're going to set each one equal to 0 and solve each one separately. Okay, I have a couple others here. Let's take this a step further. Okay, I'm going to take a look at a couple others that are already in factored form here. How about these two? Okay. Again, I have, on the one on the left here, I have the product of two things equaling 0. Okay, so I could say x squared minus 9 equals 0, or x squared minus 25 equals 0. Okay, and if I solve each one here, if I add 9, okay, so x squared equals positive 9, and then the way I get rid of the square is I square root both sides. And again, if you remember from previously, in the past, whenever we take the square root of something, I have two answers. I introduced a positive and a negative, a plus and a minus, and this would be plus and minus 3. Okay? Same thing over here. Okay? I could say x squared minus 25 equals 0. Add 25, and then I would square root both sides to get rid of the square. And x would equal plus or minus 5. Okay? But again, we can write the little equation, set each one equal to 0, and solve it. Okay? Well, those turned out to be nice numbers. Let's take a look at this one on the right. Okay? Same thing. I have a product. Two things multiplying together to be 0, so that means one of two things. Either 2x squared minus 1 has to be 0, or x squared plus 3 has to be 0. And I'm going to solve each one separately. Okay? If I do this one on the left, I'm going to add 1. And then I'm going to divide by 2. So x squared equals 1/2. Okay, now again, we don't want x squared. We want just regular plain old x. So what I'm going to do is I'm going to square root both sides. And whenever I do that, I always get a positive and a negative, a plus and a minus. And I get the square root of 1/2. Okay, now I don't want decimals. Okay, well, how do we square root a fraction? Well, one thing we can do is we can just separate it into the square root of 1 over the square root of 2. Well, good news, the square root of 1 is 1. the square root of 2 is not a nice number. And again, digging back, going back in the past, when we simplify radicals, we can't have radicals in the denominator of a fraction. Simplifying fractions can't have radicals. The way I get rid of a radical in the denominator, if you remember, is I times the top and the bottom by that radical, the square root of 2 over 2. Okay, and what I end up with is 1 times the square root of 2 is the square root of 2. And in the denominator, I get the square root of 2 times the square root of 2 is the square root of 4, which is 2. Okay, or again, once upon a time in the past here, we looked at a shortcut. 2 radicals that are the same multiplied together just equal the big number. So the square root of 2 times the square root of 2 equals big 2. Okay, we're going to come across a few of these today, a couple of them, that might have radicals in it. Just remember, your radicals always have to be simplified. You may have to make factor trees. And also remember, we can never have radicals in the denominator, so we have to get rid of them by multiplying by the square root of 2 over the square root of 2. Okay, how about this one over here? If I subtract 3, I get x squared equals negative 3. And again, to get rid of the square, I'm going to square root both sides. And I get, oh, how do you do the square root of negative 3? It's not a perfect square. Okay? And the other thing, it's negative. Well, if you remember, taking square roots of negative numbers introduces that letter I that we talked about last chapter. This becomes plus or minus I with the square root of 3. And again, that I comes out in front. Okay, and looking at the square root of 3, the square root of 3 is simplified. It can't be broken apart any further. Okay, so we're going to have a couple different, little bit fancier answers. Some may have I in it, and we have a negative number that we take the square root of. And some are going to have fractions where we have to get rid of the fraction in the denominator. Okay, I got one more batch here that I want to take a look at. Okay, how about this one on the left? Again, I have a product of two things multiplying to be 0. Let's write two equations. 3x squared minus 1 could equal 0, and 2x squared minus 5 could equal 0. And I'm going to do each one separately. Okay, I'm going to do the one on the left first. I'm going to add 1. So 3x squared equals 1. I'm going to divide by 3. This is very similar to the last one. I get x squared equals 1/3. Okay, I don't want x squared, so I'm going to square root both sides. And I'm going to separate that fraction into the square root of 1 over the square root of 3. Okay, and let's see what I have here. I get plus or minus. Well, the square root of 1 is just 1, and the square root of 3 is not a nice number. Okay, but like I mentioned a minute ago, we can't have radicals in the denominator, so I'm going to get rid of it by multiplying by the square root of 3 over the square root of 3. 1 times the square root of 3 is the square root of 3. And the denominator, the square root of 3 times the square root of 3 is just big 3. And there's my answer right there for that one. The square root of 3 over 3. Plus or minus the square root of 3 over 3. Notice that's two answers. Okay, I'm going to do the same thing over here. I'm going to add 5. So 2x squared equals 5. I'm going to divide by 2. I get another fraction again, x squared equals 5 halves. Okay, well I'm going to square root to get rid of the radical, and I get the plus or minus square root of 5 over the square root of 2. Again, if I separate them. Okay, neither one can be broken down any further, but once again, I can't have this down here, so I'm going to multiply by the square root of 2 over the square root of 2. And the two answers I'm going to get here on the numerator, the square root of 5 times the square root of 2 is the square root of 10. And the denominator, the square root of 2 times the square root of 2 is 2. And there's my answer right there. So again, that time we got a couple fractions again. We're not going to see a lot of those, but I'm just going to emphasize again, it's okay if it's fractions. Okay? Just remember we have to multiply at the top by whatever that radical is in the denominator. Okay, one more here. How about this one? Okay, again, these are already, notice they're already in factored form. Okay, again, two things multiplying together to be 0, so x squared minus 8 is 0, or x squared plus 12 equals 0. Now this one's a little bit different than the other ones. I'm going to solve each one separately. If I add 8, I get x squared equals 8. Good news, no fractions, but I'm going to square root both sides. and I get plus or minus square root of 8. Now the square root of 8 isn't a perfect square, it doesn't have a nice square root, but it can be simplified. And if you looked at your factor sheets, 8 can be simplified into 4 and 2, and the square root of 4 is 2. Okay? And my answer is plus or minus 2 square roots of 2. Okay, so we're going to extend some of the stuff we've learned in the past here and going to apply it to these factoring problems. Okay? This guy over here, I'm going to subtract 12. I'm going to square root. And I get the square root of negative 12. Now what about that? 12 isn't a perfect square. Okay? And I also see a negative sign. And we know from the last example here, when I see a negative sign, I know I'm going to have an I out in front. Okay, so I have I square roots of 12. But 12 can be broken apart a little further as well. And if you look at your factor sheet, we want to find the ones that are in black. And I'm going to do 4 and 3, because 4 turns into a 2. Okay, and if I put it all together here, what I have down here at the bottom, I have a big 2, plus or minus 2 with an I, and a square root of 3 left over. Okay, so, and as you can see here, there's a fair amount of work to show with these as well. Okay, not that you have to show every single step, because I realize once this comes back into practice and you feel comfortable with it, you're able to combine some steps. But just so we're all crystal clear, I do need to see some of this work along the way. Okay, all right, now, once again, I'm going to point out that all of these started out already factored. They were already broken apart. Okay? What we're going to do next here is we're going to put it all together. Okay? We're going to try and factor it first and then solve it. So again, up here when it says solve, we eventually want to find out what x equals. And most of these, if you remember, had at least 2 answers. Most of them had 4 answers. Okay, so let's try this one. Let's just try and factor this. Okay, it's a trinomial. I don't see any greatest common factors or anything. Okay, and if you remember from yesterday, previous day, how do I factor x to the fourths? Well, x to the fourths break apart into x squareds and x squareds. Okay, then we're going to look at the factors of 24. Okay, we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. And we need to pick the pair so that when I FOIL them, when I do this and this, I end up with a negative 5x. And if you look closely, I think it's going to be the 3 and the 8. Okay? If I did a 3 and an 8, and if I did minus 8 and positive 3, negative 8x squared plus 3x squared gives me negative 5x squared in the middle. Okay? So to me today, the hard part's going to be the factoring, breaking it apart into the different pieces. Now, once it's factored, it's just like we've been doing here in the last couple minutes. Okay, I can set each of these equal to 0 because I have a product being multiplied together to be 0. So that means x squared plus 3 has to be 0, or x squared minus 8 has to be 0. Okay, and then we're just going to solve each one separately like we've been doing. Okay, I'm going to subtract 3. I'm going to square root both sides. And whenever I square root both sides, before I even look at it, I always write plus and minus because we're going to get 2 answers. And how about the square root of negative 3? 3 is not a perfect square, but because it's negative, it's going to have an I out in front, and I square roots of 3. Okay? I can do the same thing over here. I'm going to add 8. I'm going to square root both sides. Then I'm going to get the plus or minus square root of 8. Now 8 isn't a perfect square either, but 8 can be simplified. If you looked at your factor sheet, there's a 4 and a 2. And it can simplify into 2 square roots of 2. Yep, good. Okay. Now, again, I know we looked at this once upon a time, I think. This is a heads up for future reference. This has the 4th power. The 4th power tells me there should be 4 solutions. Okay, and we'll expand upon this in the next couple days. But 4 solutions. I have 1, 2, 3, 4. 2 imaginary and 2 real solutions. Okay? And again, notice the work that we're showing here. I need to see how it factors. I need to see a little work on each solution. Okay? Here's another one. Okay, we're going to practice just a couple of these here. Okay? X to the fourth goes x squared and x squared. And 100. 100 has many factors. If you look on your factor sheet, we need to find the pair that add or subtract to give me 29. Okay, and if you look closely at those, at your factor sheet, I think you would find that 4 and 25. 4 times 25 is 100. And 4 plus 25 is negative, or 4 plus 25 is 29. But if I need it to be negative, they both have to be negative. A negative 4, and if I check it here, negative 4x squared minus 25x squared is negative 29. Okay, now this one's a little bit nicer. X squared minus 25 equals 0, and x squared minus 4 equals 0. I think we're going to see these are going to be nice ones. If I add 25 and square roots, 25 is a perfect square this time. I get plus or minus 5. This one, if I add 4, square root, and the square root of 4 is plus or minus 2. Okay? And notice the fourth power, 1, 2, 3, 4 solutions. Okay, so sometimes we get nice numbers. In fact, a lot of times we get nice numbers. Okay? I'm going to skip ahead. I'm going to do this one. Okay, how about this guy? Now this one's a little bit fancier because there's a number out in front. Okay, a 4x squared, or 4x to the fourth. Well, remember, we have to find the factors of 4. 1 and 4, 2 and 2. And then at the back end back here, the factors of 3 are 1 and 3. And we need to put them in there so we get a negative 8 in the middle. Well, my word of advice is always try the smallest one. I'm going to try a 2x squared and a 2x squared. And notice it's x squareds. Okay, and what if I tried a 3 and a 1? Maybe a 3 and a 1. Let's see what I get here. 6x squared, 2x squared. Can I get negative 8x squared? I think if both of those are negative, negative 6 and negative 2, I can get negative 8. So I'm going to put negative signs in on both of those. And it works. Okay, so again, for me, that's the hardest part is getting it to factor correctly. The rest is just a little bit of algebra. We're going to say 2x squared minus 1 equals 0, and 2x squared minus 3 equals 0. And we're going to solve each one separately. Okay, I'm going to add 1, divide by 2, and I get x squared equals a half. Okay, now I have to take the square root of both sides because I don't want x squared. I'm going to square root. And when I do this, I get the square root of 1 over the square root of 2. Well, the square root of 1 is 1. The square root of 2 is not simplifiable. But here again, we can't have the square root of 2 in the bottom. So I'm going to multiply by the square root of 2 over the square root of 2. 1 times the square root of 2 is the square root of 2. And the square root of 2 times the square root of 2 is big 2. Right there. Okay. Same thing on this side. I'm going to add 3. Divide by 2. And I get 3 halves. Another fraction. Okay. Well, I don't like x squared. So I'm going to square root both sides. Okay, and this time I get the square root of 3 over the square root of 2 if I separate the fraction. Again, neither one individually can be reduced. Okay, but I can't have this down here again. So I'm going to multiply by the square root of 2 over the square root of 2. Okay, my numerator turns into 3 times 2 or the square root of 6. And the square root of 2 times the square root of 2 turns into big 2. And there's my answer right there. Okay, and I got 1, 2, 3, 4 answers. Just like I should, this tells me right up here, the degree, the highest power is 4, tells me I should get 4 answers. Okay? All right, so those are a lot of common ones. 3 terms. We just kind of do our regular factoring. We try to get the middle number, trinomials. Okay? And then the solutions. Okay, let's take a look at something we focused on yesterday. Okay, perfect cubes. Okay, and here's a little pattern, a little rule for factoring perfect cubes. If I look closely, x cubed is a perfect cube, and so is 27. Okay, and so the way that this works, remember it had a little piece and then a big piece. Okay, the little piece came from the cube root of each one of these numbers, is what goes in the first parenthesis. Well, the cube root of x cubed is x, and the cube root of 27 is 3, and I kept the same sign. Okay? And once I got that first piece here, I used the first piece to make the big piece, the second part of it. Okay, and the way that I got this first number is I took the first number, the first letter, squared. So the number that goes here is x squared. I then changed the sign, and I multiplied the two, 3x. And then I squared the last number. Okay, that was a refresher from yesterday when we factored perfect cubes. Okay, and hopefully you wrote this down yesterday. Or if not, write it down right now. It's going to be handy. Okay, so I've got it factored into its two pieces, and now I need to solve it. It's still equal to 0. Okay, well this first part, I can set it equal to 0 and solve it, and I get x equals negative 3. And maybe once we do a lot of these, a lot of you guys can just skip to x equals negative 3. It's the opposite. Now yesterday, when we did perfect cubes, I mentioned this a couple different times, that this second part is not factorable. Okay, so I can't do two more parentheses and set them equal to 0 and solve it. Okay? To make a long story short, the way I find the zeros or the solutions to the second part of this is we must use the quadratic formula. Something we've worked on in the last chapter. Okay? And in case you forgot the quadratic formula, it looks like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, maybe you want to take a second and jot that down again. Okay? When I use the quadratic formula on this one, we need to make sure we identify what a, b, and c are. A is 1, b is negative 3, and c is 9. Okay, and I'm going to use the quadratic formula on this last part. Okay, so it's going to look something like this. X equals opposite of b, so it's going to be positive 3, plus or minus the square root of b squared. Negative 3 squared is 9, minus 4 times 1 times 9, all over 2a, and 2 times 1 is 2. Okay, now when we do the quadratic formula, okay, we want to simplify the stuff under the radical. Okay, and if I grab my calculator, and I was to do 9 minus 4 times 1 times 9, 4 times 1 times 9, I get negative 27. Okay? And once again, when we did the quadratic formula the first go around in the last chapter, we always had to look at this and see if it could be simplified. Is 27 a perfect square? No, it is not. But it can be reduced, it can be simplified, it can be broken apart into the square root of 9 and the square root of 3. And 9 turns into 3. Okay, and so what I have here at the end, I get 3 plus or minus 3, and because it's a negative 27, there's an I with it, a square root of 3, and all of it's over 2. Okay, and again, there's a reason why we practiced the quadratic formula before, because we're going to use it, and we're going to continue to use it in this part of the chapter as well. Okay, if I go way back to the beginning here, I'm going to point out, this is a little thing that's going to help us in the future. It started out with a third power, so we should get 3 answers. And I did get 3 answers. I got 1 of them here, 2, 3 of them right there. And remember one last thing with the quadratic formula. If we can divide something into all 3 of the big numbers out in front, we need to reduce it. We can't in this case, so there's my final answer. Okay, I'm going to do one more here, a perfect cube one. Let's see if we can try one more here. If I look closely, I want to solve this. My directions are solved. 27 is a perfect cube again, and so is 8. The cube root of 8 is 2. Okay, so when I break this apart into my two little pieces here, the first part's the cube root of 27, which is 3 with an x, and the cube root of 8, which is 2. Okay? And then what I do is I use this first part to get the second part. I square the first number, which is 9x squared, change the sign, and multiply the two together, which is 6x, and then I square the last number. Okay? And all that's equal to 0, so I want to solve it. Okay, now some of you might be able just to look at this, okay, and see that the answer should be negative 2/3. The opposite of 2 divided by 3. So if you want to write just x equals negative 2/3, you sure can. Otherwise, do what we've been doing here, set it equal to 0 and solve it. If you subtract 2 and then divide by 3, that's how we get negative 2/3. Okay? And knowing what we know now about this part of it, to solve it, we have to use the quadratic formula. Okay? And I'm going to write A is 9, B is negative 6, and C is 4. Okay, so if you wrote down the quadratic formula a minute ago, let's use it. Okay, x is going to be equal to the opposite of b, which is 6, plus or minus the square root of b squared. Negative 6 squared is 36, minus 4 times 9 times 4, 4ac, all over 2a. And 2 times 9 is 18. And again, the next thing we want to do is we want to simplify all of that and get one number under the radical. We don't want to get too calculator happy yet. So I'm going to take 36 minus 4 times 9 times 4, and I'm going to get negative 108 down there. Okay? Okay, now, once again, I see a negative under there, so I'm thinking, oh, there's going to be an I in my answer. Okay? But let's check and triple check here. Is 108 a perfect square? No, it is not. Okay? If you looked at your factor sheet at 108, and you went down the column and you found the black ones, you would find that 36 and 3 give you 108, and 36, the square root of 36 is 6. Okay, so if I kind of put this back together here, hang on a second. I put this back together. I have 6 plus or minus 6 with an I because it's negative, square root of 3, all over 18. Okay? Now, like I mentioned a minute ago, if I look closely, all three of those numbers can be divided by 6. So I'm going to divide them by 6. I get a 1, and a 3. And this is something I saw when we did the quadratic formula the first time. If this cancels out, it doesn't turn into a 0. There's a 1 there. We need to keep the 1. Plus or minus I square roots of 3 all over 3. Okay, and again, just so we're all crystal clear, this is the type of work I expect to see. Okay? Your work needs to match your answers. Okay? And again, I got 3 answers. Okay? And they're, okay? All right, so that's ones, those are some ones we did with perfect cubes. Okay, there was one last type of problem that we worked with factoring the other day, and it was by grouping. Okay? And when we did grouping, it was most oftentimes when there were 4 terms. Okay? And we're just going to do one of these. We're going to factor it, and then we're going to solve it. Notice how it's equal to 0. So if you remember, the way grouping worked is we grouped the first 2 numbers and the last 2 numbers together. Okay, and you can see there's a subtraction sign in between the 2 groups. And we talked about this previously as well. When there's a subtraction sign in between the 2, we need to change the sign on the very last number. So instead of it being minus, it needs to turn to a plus. Okay? And then with grouping, the way it worked is I looked to factor out the greatest common factor of the first group, the first parentheses. And if you look carefully there, each of those have an x squared in common. So I'm going to take out an x squared. And I'm going to get an x plus 5 left over. if I take the x squareds out. Then there's a minus sign. If I look at the second group, they each have a 2 in common. So I'm going to factor out a 2. And if I divide out a 2, I get x plus 5. Okay, and then kind of the whole crutch, the whole key to grouping was they now have a little expression in common. And I'm going to take that expression out of both of them. They both have an x plus 5. And if I take out that x plus 5, you can see that I have an x squared minus 2 left over. And all of this is equal to 0. Now, when we did grouping before, we kind of stopped right there. Okay? But now, since we're trying to solve it, I'm going to try to find the zeros. Okay? So I'm going to set this one equal to 0. And I'm going to set this one equal to 0. And I'm just going to solve. Well, again, you might have seen the shortcut here. If I subtract 5, x is negative 5. Okay, on this other one on the right here, if I add 2, okay, and then I have to square root both sides. So x equals plus or minus the square root of 2. Okay? And there we have it. Okay, so grouping, I say the biggest thing here is getting it factored apart into its different pieces. And once we have it factored, then really it's just a matter of writing 2 equations, setting them equal to 0, and solving each one individually. Okay? All right, thanks for tuning in.